So yeah, welcome everyone. I hope you guys are doing extremely well. So this is the problem that was given in August long division, XOR with smallest element. Let us first of all look at the problem statement. Initially he has given an array A of length n, right? You need to find the smallest element in that array and he will give you an element x, so that you need to XOR your element x with the minimum element, and you need to keep on repeat that operation some y times. He'll give you the y. So before going into this problem, let us understand what is XOR, right? I'll say the XOR is an odd number of ones detector. See, if there is 7, what is its binary representation? It was 111. If there is 4, it will give you 100. These are the binary representations, right? If I say what is the 7 XOR 4, you'll see you'll see at each position what are the present number of ones in that bit. See here there are one number of ones, right? Here there is one number of ones. Since my number of ones is odd, as I said before, it is an odd number of detector. If there are odd number of ones, I'll keep their one, right? Because it is an odd number of ones detector, I'll make sure that my XOR will return one, right? See, if you go on to this position, ones are 0, and again here odd number of ones are present, so I'll keep 1. So if you go over here, there are even number of ones. I said before that XOR is an odd number of ones detector. Since here there are even number of ones present, it won't detect. So what is the resultant number? This is, if you convert this into your from binary to decimal, it will be 3. So you can check this element. So whatever, if you need to perform the XOR operation, first of all you need to check that it is an odd number of ones detector. So in every position there should be odd number of ones, right? If there are even number of ones or zero number of ones, then it will give you 0. You will make that as 0 in that position. So it is the first of all the basic understand that you need to have. Now let us go with the problem. See, initially he has the first test case was 1699, right? So this is our x and this is our y and this is our n. So the our array element is 9. So you need to find the minimum element in this array and you need to XOR this element, which is 9 XOR 6, that was 15. 9 or 6 is 15. If you wanna know how it came, like you can do this 1001. The binary representation of 9 is 1001, and the binary representation of 6 is 0110. This is the binary representation of 6. So if you XOR with this element, you'll get 111. Since every bit has odd number of ones, you're getting your resultant bit as 1. So what is this number? This was 15, right? So this is the XOR. So you need to perform this XOR operation until 99 times repeatedly. Now your array will become 15, right? Now your array will become 15, and again you take the minimum element in the array and you again XOR with the 6, which is 15 XOR 6, that was again 9. And you need to keep on repeating this operation. But I need you to understand one thing. Like if you say 9 XOR 6, that was 15, right? If I say again I XOR with the same element, I'm getting this whole resultant as 9. Then what does it mean? If you XOR the same element even number of times, then they cancel with each other. Why? Because you get even number of bits in that position, which won't make any difference in your resultant number. So if you XOR same element with even number of times, then it won't affect your number, it will cancel with each other. And if you again XOR with the 6, if you again XOR with 6, since there is an odd number, some even number of times gets cancelled, and again 9 XOR 6 will give you 15. So this process keeps on repeating, right? Since my y is 99, which was an odd number, some 98 times, which was even, right? So 98 times or 6 will get cancelled with each other, since it is an even number of times. Now my only one time will be remain, and that one time, which was 9 or 6, will be 15. So let us see another test case, which was 3744, right? This is my n, and my x is 7, right? Yeah, my x is 7, and I need to perform this operation this number of times, which was y number of times, that was given as 44. And now my n, my array is 1 2 3. Now my array is 1 2 3. So what I'll do over here is, first of all, I'll I search for the minimum element, which was 1, right? Which was 1. Now I XOR with my x, that was 7, right? What is 1 XOR 7? What is 1 XOR 7? That was 6. So it will, now my array will become 6 comma 2 comma 3. Now you will again take the minimum element, which was again 2. What is 2 XOR 7? What is 2 XOR 7? That was 5. So now my array will become 6 comma 5 comma 3. Now you'll again take the minimum element in your array. What is the 3 XOR 7? That was 4. That was 4. Now my array will become 6 comma 5 comma 4, right? Now I again take the minimum element, which was 4. What is 4 XOR 7? That was 3, right? That was 3. And if you take again, the minimum element will be this, and this process goes on repeating, right? And this process goes on repeating until my y number of times are getting over, right? So the main observation that you need to know over here is, if an element, if my same element gives me two number of times. See here, this position has already given me the minimum position previously, and if my resultant, which I have already XORed with my x, even that is giving you the minimum element in array, can I say this, that my operation will only apply to this position only throughout my process? Can I? Because see, if the initial element was 3, and if my resulting, which was 3 or 7, which was 4, and that was 2 minimum element in the array, so it goes on repeating, the operation will goes on repeating at this element only, right? So what I said previously, if you XOR the same element even number of times, then it gets cancelled, right? Then it's get cancelled. uh, yeah, we'll see this. If yeah, first of all, we'll take that example only, which was 1 2 3, right? Which was 1, yeah, 1 2 3, 1 2 3, right? First, for y equal to 1, I XORed this, which will, yeah, my x is 7 and my y is 44, right? My y is 44. Now I'm performing this operation. 1 XOR 7 gives me 6, and this 2 3. This is the first, for the first time operation, right? Okay, I'll make this. Yeah, after my first operation my array will be this, and after my second operation it will become this, which was 2 XOR 7, that was 5, right? After my third operation it will become 6 comma 5 comma 4, 6 comma 5 comma 4, since 3 XOR 4 is 4, right? Right. Now you see, again the minimum element is 4, which was again you need to XOR with the same element. You have already previously you XORed something which was 3 XOR 7, which had result, which you have a result of 4, and again you're XORing the same element, that position, right? Which was again 7. So since it is an even number of times, since this will be get cancelled, and again it will result, and then again it will give you result as 3. So what you need to observe is you don't have to go you don't need to calculate throughout this process. Once if you know what are the number of times that I need to perform this operation at this element, if it is an even number, you'll just keep your element alike. If it is an odd number, you'll just XOR with the element one time. Can I say this? Since, see, what is the answer he has given us? That was 356. Since we have to output this in an sorted order, if you carefully observe here, we have already performed two operations over here, and if you performed over two operations over here, after this you're performing the same operation on the same element. After two operations it is the array, right? So what are the remaining number of times? That was 42. So since you are performing 42 operations on the same element, which was an even number, what if it is an even number, all will gets cancelled, right? Since XOR is an odd number of ones detector. So what will be your resultant array? That was 653, right? That was 653. Since you have to output in this sorted order, it will become 356, right? It will become 356. So let us have a look over this, which was 520 526. Okay, you need to perform this many number of times, and the array was 5, 10, 15, 20, 25, right? 20, 25. Now you'll pick this minimum element and XOR with this. What will be the answer? Then it'll give you 17. So since you can see, as he was given in the test case, you will pick the minimum element and you XOR with this, and it will become 17 after the first operation, and still there are 5 operations remaining, right? And after the second operation you'll pick the minimum element, which was 10 over here, and you'll XOR with that, and the resultant will be 30, and you again pick the minimum element, which was 15, and you XOR it with 20, and the resultant will be 27. And after performing this operation 2, again you are backed with the previous element, which was 17. See, again you got the minimum element as 17, right? Which has, if you have already performed the operation and you are getting again that element as your minimum element, and the process will go on repeating from here, right? See, if you XOR with the 17, if you XOR 17 with 20, you will get again 5. If you XOR with 20 with 5, you will get again 17, and you will get again 5. So this process keeps on repeating. So what I was trying to say is, once if you have achieved, once if you are performing the same operation on the element that you have already performed the operation, you just look at the number of operations that are remaining. Here there were 3 operations remaining, right? After three steps, there are three number of times, three number of operations that were remaining for this minimum element, right? For this minimum element. So even number of times will get cancelled, and I need to perform this operation one time, one time on this 17, which will again give me 5, which will again give me 5. So I think you have understood this. See, I'll explain this. If you have 5, 10, 15, 20, 25, right? Yeah, 5, 10, 15, 20, 25. I'll write stepwise. I'll write stepwise. For step 1, if you XOR 5 with 20, if you XOR 5 with 20, then the resultant will be 17, 10, 15, 20, 25. Again, you'll pick the minimum element and you XOR with this 20, right? And what will be that element? What will be that element? That was 30, right? Now my resultant array will be 17, 30, 15, 20, 25. This is step 1 and step 2. And after this, you'll again XOR the minimum element with 20. And what is the resultant array that you're getting? Which was 17, 30, 27, 20, 25. This is the third step. After this, the fourth step is again, it is again the minimum element that you have already performed the operation previously. See, you have already performed this operation previously at this position. If you are getting that position next time, then you need to understand that this process goes on repeating, right? See, again I'll XOR with this 20, which will give me 5, 30, 27, 20, and 25. And again I'll XOR with this 20, which will again give me 17, 30, 27, 20, 25. And if I again, for step number 6, I again XOR with this 20, which will again give me 5, 30, 27, 20, 25. See, what I was trying to explain over here is, since if you're keeping on performing this operation for unique elements, if you're performing the operation on the same element, when you're getting the same element next time, then you need to understand this, the process will goes on repeating, right? See, since I have XORed with the same element some even number of times here, right? Some even number of times, which is 1, 2, 3, 4. I have, sorry, okay, I have performed the XOR operation with four times on the first position. See, here 1, here the first time, and here the second time, and here the third time, and here the fourth time. Since I have performed even number of times XOR with the same element, I was getting the same element which was present in my original array, that was 5. I was getting that same element, right? So that's what I was trying to conclude you, that if you perform the if you perform the XOR with even number of times, then it will get cancelled. You don't need to make each and every time operation. So for that, you need to check how many number of times I need to perform this operation. If it is an odd, then you need to perform this operation for one time, then it will be enough. Why? Because if I need to perform this operation for 3 times, for 2 times it will get cancelled, and one time it will be remain. If some like 97 times are there, then 96 times get cancelled with each other, and 97th time, that one time you need to perform this operation. So that's what I was trying to conclude. So you just so as a result, we need to take the minimum element in this array. You don't need to iterate for every iteration, right? Because it will give you TLE. So we need to use a priority queue over here, which will give you the uh, resultant answer. So I'll just quickly show my code. Sorry, yeah, I'll just quickly show my code. See, here I was just taking the input and x and y. Here I was taking my array as input, which was vector. Now I'm taking my priority queue. Why I was taking this priority queue? For the minimum element. For every time I need to take the minimum element from this array, right? So my priority queue will make that element available for me. So I'll push all these elements in my priority queue, and it will arrange in a sorted order, and I'll get the minimum elements, right? So I need to perform this operation for y number of times, right? So I'll take my minimum element from this priority queue. It will give me my minimum element of the array, and I'll check whether if I XOR with my x, I'm getting greater than my minimum element or not. Like, see, if I'm getting if I'm not getting a greater than element after even I have performing the XOR operation, which was here. I'll just remove over this. Yeah, see, at this step the minimum was 17. Even after performing the operation I was getting 5. Even that was minimum element too, right? Since this both are element, if it is a minimum element, then you don't need then from that step this process will keeps on repeating. So that's what I was taking here. If it is the minimum element again, I was breaking here, and I was checking how many number of times, how many remaining number of times I need to perform the operation. If it is an odd, I just perform that operation, and I'll remove that element. See, why I was popping this element is, if I get, like, for this example, like priority queue will store in this order, right? 5, 10, 15, some 20, let us say, like this. And it will give me 5, right? It will give me 5, which was pq dot top is 5, right? And I'm making it as I'm XORing with this. See, I was XORing with this element, which was my mini, that was equal to pq dot top, right? I was XORing with this element, and I was pushing this element, and I was popping this element. Since we are changing the 5 with 5s or 20, I will pop this element, and I'll again push this element into this. Now my resultant array is this, right? So that's what I was doing over here, which was I was popping that element, and I was pushing my XOR element with this, and I was decrementing my y. If my since if my minimum element is only changing, by the explanation part, I think you will understand this condition, right? So if there are odd number of times, then you need to perform this, and then since it will store in the sorted order, I'm just printing my priority queue elements directly, that was from top. It will give me in the sorted order. So I think you'll understand this. If any doubts are there, please let me know in the comment box.